All right, so in this class, as I said, we are gonna solve inequalities and inequalities that are involved in polynomials, and polynomials of degree 3 is what we are looking at. So remember, we did the long division, so it was very cardinal to understand that. Also, the synthetic division, if you are able to watch that in that YouTube video as well, it's very cardinal to understand that because that's what we're gonna use here. I'll not use long division in this one, but instead I'm gonna use just synthetic division. So we do question A, and I think we'll do C. Okay, so question A has the question, this is x cubed plus 4x squared minus 7x minus 10, and we're saying this should be greater than what? Greater than 0. Notice that it's strictly greater than 0, what they're requiring us of here. So what do I have to do? First of all, I have to factor this polynomial here. So initially, if you had an equal sign, you would have something like this: x squared minus 7x minus 10 equal to 0. If you have an equal sign like this, it means you have solving for the values of x. And as we learned, when solving the values of x, you have to factor this out into linear factors. Maybe you have about 3. I'm just writing randomly these. Let's say you have something like this. And what you do, you equate each and one of them to what? To 0. Then those are the values of what? Of x for this that satisfy this what? This polynomial. But when you're dealing with inequalities, what you're interested in when you're dealing with inequalities is a set of values. It's not only one value, but it's a set of values. So that's why you have this greater than symbol here. You're looking at what number of values are gonna satisfy what you're talking of. So it's like you have a range, you have a set, there are a lot of values. So anything within that range or within that set of values is going to want to make the inequality still to be valid. Okay, so we go in that way. Other concepts I will explain even as we go along. So first of all, we use the same rational root test, which we're looking for in order for us to find out a root. And remember, we said this here, if we say 10 here, we let our 10 to be our p, and we let the coefficient of the highest degree, which is x to the power 3 here, the coefficient is what? Is 1. So we let that 1 here to be equal to what? To be equal to q. Then we say we find p over q. That's why it's called the rational root test, because you use this in order to find what? In order to find a possible root or a root of what? Of this polynomial here. So what do? You get the factors of what? Of this p, positive and negative, that is. So you have 1 is a factor, you have 2 being a factor, you have 5 being a factor, and you have what? 10 like that being a factor. And you're dividing by the factors of the q as well. Factors of 1, just positive and negative, of course, that's plus minus 1. And this here will give us what? Plus minus 1. When we divide plus minus 1, we just get the same things here. That's what we're gonna get. Okay, so plus minus 10. Then what you do is you get one of these numbers here, and after getting this, you're going to replace in this polynomial here, and you see which one will give you what? Will give you 0. Okay, so for the sake of testing, though I did test them, so let's say we get 1. I replace 1 here, so I said we get the 1 there. After getting the 1, then we want to cube this one, since that's what it's saying, then plus 4, then 1 squared there. And after 1 squared, what do we do next? We're gonna do 1 squared, 4 here, then you have 7, like that, then minus 10. So here, this gives us 1, this gives us 4, this gives us negative 7, that gives us negative 10. And here we just get like 5 over minus, this here will be 17. 17 minus 5 is negative 12. Negative 12 is not equal to 0. So this one is not a root of this polynomial. So you test the other one. So test the other one, like the other version of it, which is the negative. So let's test -1. So we're now testing x equal to -1. So we place -1 there cubed plus 4 -1 squared minus 7 -1 minus 10. This gives us here to be a negative since this is raised to the power to an odd power. So -1. This will be positive since it's raised to an even power. And you get 4 there. This here gives you negative by negative gives you a positive. It's a positive. Positive 7, and you have this there minus 10. Notice when you add this there, you get -11, and you just have 11. 4 plus 7 is 11, so you like have 11 minus 11, which is equal to 0. So this means that x equal to -1. This -1 is a root of this what? Of this polynomial. It being a root, you use it in order to now simplify it. So if you have x equal to -1 to be a root, it means that x plus 1 like this is a what? Is a factor. This is like a linear factor of it. So you can use synthetic division from here, where you just say -1, -1, say -1 here, then I do that like that, and I get the coefficients of get the coefficients, as I was saying, get the coefficients. So the coefficients of the polynomial, you have 1 there, you have 4, you have -7, and you have -10 there. That's what's there. Then now here, it's 1, there's 0 here, there's nothing. So you add 1 plus nothing gives you 1. 1 multiplied by the negative there gives you -1. Add here, you get 3. So 3 by the negative gives you -3. So -7 plus -3 gives you -10. Multiplied by the negative, it gives you +10. And this gives you 0, the remainder of 0, which we got before. So we factored it out here. So this is just x squared plus 3x minus what? Minus 10. This is what we have. And remember, the first part of it was x plus 1, like that. So this is what we get. Then we have to also simplify this into, simplify that as well. So what do we do? I think here I can get my product. Product is -10. My sum is 3. So my factors, what are my factors? My factors are going to be 5 and -2. Because when I add, I get 3. When I multiply, I get 10. So I can factor this out. And when I factor this out by grouping, I just get x plus 1, the first one here. And the other ones are just going to be what? X minus 2. And have x plus what? Plus 5. So I factored this out, factored it out completely, or factorized it completely. Now I go back to my inequality after getting those there. So I go back to my inequality now. So what am I going to do with it? So I'll say what we want here, it has to be greater than 0. So we've just factorized 1 plus this minus 2x, then I have x plus 5. We're saying this has to be greater than what? 0. So it has to be greater than 0. So now what do we do here? From this stage, we have to find what we call critical values. Because we're dealing with inequalities, we're going to use a critical table in order to find our values. So to get those critical values, just equate this thing to 0 here, which means you have this linear factor equal to 0, this linear factor equal to 0, this linear factor equal to what? 0. Then find the values of x. And you have values of x to be -1, you have values of x to be 2, and you have values of x to be what? -5. So these are our critical points here. These 3 are our critical points, and we use them in our critical table. So I'm gonna draw my critical table. So my table is going to look like this. First. Okay. Show it like that. So here, it's the first value I'm going to put -5. I go there, I'll put the other one, which is what? -1. So I put them in ascending order. Then I'll have 2 here, then like that. So these are my critical values that I have. So, or critical points that I have. Okay, so from there, what do I do next? I place now these linear factors here in the first in the first column. So what did I have? I have x plus 1, the first linear factor, like that. Then I have like x, x what minus 2, like that. Then I have x plus 5. And the last one involves all the 3, which is just exactly what we have there on top. But I don't have space here to write them, in just one line. So I'll write it there, minus 2. Write this one here down, but just you to understand that it's in one line, like that. So what I'm interested in is not really what values I'm going to be getting, but the sign of those values. So what you do now, you start testing points. So here in the first column, in this column here, what you're getting, these values are the x values that will be less than what? -5. Here, these are values of x that are going to be between -5 and what? And -1. So x will be between -5 and -1. Here, x will be between -1, like this, and 2. And of course, here x, we expect x to be greater than what? Than 2. So what you do now, start picking out what? Picking out values. So you pick out values in this first one. So pick out values that are less than -1, -5. So let's say -6. So if I put -6 in this equation here, what I'll have -6 plus 1, which gives me -5. So I check what value does this give me. This is a negative sign, it has a negative sign. So means everything that I'll pick here that is less than -5, I'll have negative. So you do the same for the next one. Pick out and you just see negative here, you have still a negative sign. Here you pick out and you still have what? You still have a negative sign. Then the next thing is you just multiply this. Since you see that this is multiplying that, multiplying that. So multiply these 3 signs, and that's going to be your value here because that's what you're doing here. So negative by negative will give you positive, positive by negative, gonna give you still negative. So you get negative here. Then you pick out the next value, values in between here. What values are those? Choose whatever value. I choose to choose -2. -2 there gives me what? This here gives me a negative. Put -2 there, I still get a negative. -2 here, I'll get a positive. I multiply this negative by negative, positive, positive by positive gives me positive. Go to here, what's in between, or choose values in between -1 and 2. I choose 0, put 0 there, I'll get a positive, put 0 there, get a negative, put 0 there, I'll get a positive. What do I get? This positive by negatives give me negative, negative by positive still get a negative. So this will give me a negative. I choose value greater than 2. I'm gonna choose 3. 3 there still gives me a positive, 3 there gives me a positive, 3 there gives me a positive. And roll this out here, I'll get a what? A positive. Well, what am I interested in now? What I'm interested in is this sign here, greater than sign. So greater than 0, it means I have to be getting values that are greater than 0. And values greater than 0 are positive values. So I need to pick out those sides which are positive. It means here it's positive, there it's positive. And those are going to be what? My values that I'm going to get. So in short, your solution set is just going to be what? To be equal to. What are these values here? So there you have x being in between what? -5 and -1. Now look closely that this is greater than 0. So there's no equal to. So meaning we strictly want it to be what? Greater than 0. And you notice if we put a greater than or equal to, let's say you get -5, because -5 would mean it to be equal to. You replace it in this equation. What you'll be getting is you'll get a 0, but we don't want to get a 0. So meaning our solution set strictly will be greater than. So that means we'll have open sets here. I'll write it in interval notation. So we have -5 going all the way to our -1 is the first one, which is here. Then this one union what? Union, it goes from what? +2 to what? To infinity, like that. And it's open on both sides because we want strictly greater than what? Greater than 0. Where they're telling me to show this on a number line. And I'm glad I learned to pick one, so I'm able to show this on a number line. This will go from -5, I have -1 there, let's say I have 2, and of course that there is going to infinity. And I can show this here to be open, going all the way to there to be open, from there to be open, up to what? Up to infinity to be open. So this is going to be what? The solution for this polynomial inequality. Alright, unless there's any question here, we'll do the last question and call it a day because the network is really bad. Any question? We clear? Okay, I guess the silence means we are clear. So let's move on to question C. So how do we do question C now? So for question C, you have 2x cubed minus 5x squared minus 8x plus 20 is less than or equal to what? To 20. So it is less than now or equal to 0 now. Strictly less than or equal to. So now what are we going to do? You want to find your possible values. And remember, use the same here. You say P, Q, and you get the factors. Then you find the rational one using the rational root theorem. So factors of 20 plus minus that, plus minus 2, plus minus 4, plus minus 5, then you have a plus minus a 10 and a plus minus what? 20. And of course you're dividing by factors of 2, which are just going to be plus minus 1 and plus minus what? 2. You divide this and you get different values, you get 1. So if we divide by 1, we just get the same values, which is plus minus 1, plus minus 4, plus minus 5, and plus minus 10, plus minus 20. You divide by 2. So when you divide by 2, of course, when you divide into the even numbers, you'll be getting these same numbers here, but divide into the odd numbers like 5 there and like 1 there. You're gonna have now put something like plus minus half here and a plus minus 5 over 2. So these are going to be a possible roots which you can use. Well, go directly and test. So test x equal to what? Test x equal to 2. So test x equal to 2. So it means I replace my 2 here like that. 5 squared. 2 there. And we have 5 like that. 5 squared. Then minus 8, 2. Then plus 20. So we work out this, what do we get? Here we square, we get 8, 8 by 2 gives us 16. Here you square this, you get 4, 4 pi, that gives you 4 pi. 5 gives you 20, square that you get 16, and you have 20, and this most definitely gives you 0. So 2, x equal to 2 is going to be a root of this, and if x is equal to 2 is going to be a root, so x equal to 2 is a root, that means x minus 2 is a what? Is a factor of this. So then I can replace or use synthetic division. I say 2 there, then I get the coefficients like that, -8 and 20, and I can simplify this. Just bring it down to be 2, 2 by 2 gives you 4. Here you add, you get -1, multiply gives you -2. You add this, you get -10, multiply, you get -20, and this gives you 0. So this factors out to 2, x squared minus x minus what? 10, like this. And then, of course, you can use whatever method you're gonna use. Find the factors here, as usual, because I can really find, so -20 is my product, my sum is -1, so my factors -5 and 4 are my factors. Then I can factor this to 2x, and this will be just x. This will be x. So I factor this to be x plus 2, and to be x, 2x minus what? Minus 5. So just check that you get this when you factor that out. So that's what you get. Then next, what do I do here? So we factored this out. So just find your solutions now. Let's find your critical values. Critical values where you equate this to 0. Try equating that to 0. What would be your values of x that you get? Values of x equal to 2, x equal to negative 2, and you have the value of x being equal to 5 over 2. So that's what you get, 5 over 2. Okay, so after getting that, now what are you gonna do with that? Okay, somewhere where it looks like okay, so yeah, like that. So we get these values here. So now we can come up with our table. So come up with our table, and so let me write this again. The way it factored out was 2x. That was 2x minus 5. Then I have x minus 2 and x plus 2. This has to be less than or equal to what? To 0. Coming up with your table again. There. You have it like that. Here in the first one, you can put whatever those linear factors, x minus 2. You have next one is x plus 2. Then you have that is 2x minus 5. Of course, and here, this here, what we have, the way it's written as a linear factor to be here. I won't write it, but I'll say that linear multiplication, yeah, I know you know what I'm talking about. So that's there. Then I can now get my, so I've already gotten my critical values. The lowest was negative 2. The one that followed was 2, and the one that followed was what? 5 over 2. So this here would mean this is x less than negative 2. This is when x is in between negative 2 and 2. And there is when x is in between 2 and 5 over 2. And here when x is greater than 5 over 2. Okay, so you check now these values. So when you replace your values, replace anything less than negative 2. Here you expect a negative. Here less than negative 2. You expect a what? A negative there, negative. And this here just gives you what? Doesn't give you a positive, it has to give you a negative. Gives you a negative when you multiply these. Since we're multiplying here, so we multiply negative by negative by negative, which gives me a negative. Do the same here, get a number in between here. You can check, you put 0 there, just get negative here, get positive here, get negative, get positive. Here you get a positive, then negative, of course, then negative, then at the end here, anything greater, you just get a positive, 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 positive. So this is what you get. So now, what's our concern? What we want, the question is asking us to find anything less than or equal to what? To 0. So the less than is this part here, negative, because you expect it to be 0 and what? And negative since it's less than. So negative there and negative, those are our regions. So our solution set is going to be, so the first one you see it's from what? Negative infinity to, so now here it's okay for it to be equal to 0. So meaning negative 2 can be part of what? Can be part of the solution. So going up to negative 2 and now close there, it's going to be part. Then union, here this solution is going to be 2, then 5 over what? Over 2. So these can be part of the solution because there's equal to there. So if I replace that, if I get a 0, then it's fine because they've said it can be less than or equal to what? To 0. So raise this table here. After doing this, then I can write it, my solution on a number line. So you have that there, that. So negative, so you say negative 2b here. Then I have 2, and I have what? 5 over what? Over 2. So the first one, -1 to 2. So here to -2, I mean, all the way to that side. Then the other one is just from here, closed because of the brackets there, like that. This is gonna be a solution. This is how you work out questions involving these inequalities of polynomials. And even if you had quadratic equations, you'd still do the same way. It's just that you have these linear factors. You have two linear factors than in this case where we have three linear factors. Unless there's any question, but this is where we end for today's class. Do I have any question?